Okay, cool. Let's get started. Welcome to the final week of the Launch School Prep webinar series. So just as a reminder again, these webinars are standalone and they don't require you to have attended previous ones to understand what's happening in this one, as each webinar is its own standalone topic. However, it's not that you'll need the previous webinar in order to understand what's happening in the next one, but some of them do have prerequisite knowledge that in which this webinar is the most applicable if you are in the process of going through Launch School's prep course, right? So I mentioned before, my name is Grace. I'm a TA here at Launch School, but also like most TAs at Launch School, I'm also a student in the JavaScript track myself. So I've also been to the prep course, and I've also been in the same shoes as you are now, completely new to the material and in the beginnings of this journey towards mastery. So as usual, this is a safe space for everyone to learn, but I always encourage everyone, especially to make mistakes, since mistakes are where you're going to learn the most and when it's going to be burned into you the most. And of course, to ask questions, right? So remember that there are no dumb questions here. The only thing that I ask is that Zoom has this Q&A feature, and I just ask that we submit questions to the Q&A feature, as the chat is more for idle chit chat, and especially today I'll be prompting the chat a lot for some of the answers. So a question might get lost in the chat. So yeah, please just submit the questions to the Q&A feature there. You're highly encouraged to code along and kind of just follow through the process today, especially today more than the other ones, and just try out the examples that I'll be showing. As well as maybe even kind of following along and trying giving it your own approach today. However, that's totally fine if it's difficult to follow along or if you're feeling overwhelmed. I would say try not to worry about it and just feel free to watch along. There's still a lot to gather from that. And I'll be doing my best to make this session as interactive as possible today. And that's because all the material that's covered in this session today isn't anything that's not covered in public-facing resources that Launch School provides. So today's specific webinar is centered around this Medium article that I just sent in the chat. So this is a confirmed link that you can feel free to click. So I based this entire webinar and this lesson plan today on this Medium article. So if you miss anything today, we don't give out the slides and we don't give out the recordings, but the exact breakdown of what I'll be talking to today is in that Medium article. So feel free to reference it and go through the problem once again after this session's over. And we're simply using this as an opportunity to make the learning experience a more interactive one, rather than reading through the entire Medium article. So as usual, I'll be using Amazon Web Services Cloud 9 service today. This is a coding IDE environment that they provide. And it's usually what we recommend for those starting out, just because it's a consistent environment. And often when people are starting out, they can have different environments, different operating systems that can make it sometimes hard to debug certain problems. With Cloud 9, everything is just consistent. The exact same environment is created. And it's a lot easier to maybe debug certain problems. So it's what we recommend for those starting out. But really you can use whatever coding environment that works for you. So make sure you just simply have access to a terminal with Node installed. That's down here. That's the terminal. And if you're joining us for the first time today, you don't really have to do anything here. As long as you just open up Cloud 9, you should see a window similar to what I have right now, and it's just ready to go. It already comes installed with Node, so you don't have to do any additional work. Okay. Awesome. So specifically today, what we're looking at is we're going to be taking a look at what the PEDAC process is, right? I say PEDAC, some people say PEDAC. So we're going to be looking at the PEDAC process, what its advantages are, and how to approach each step in the PEDAC process. We'll then be using the PEDAC process on an actual problem from the Launch School JavaScript Small Problems Test Bank. So this is an easy level problem today. There are medium and advanced problems available in the test bank, but we'll be tackling a small one just to see it's PEDAC in a basic form of action. I'm going to be going through also how to read the stack trace, which is what informs us of errors that may happen in our code, including the type of error and where or how it occurred. Lastly, if we have some time, I'll be demonstrating some additional tools that are useful for debugging errors in our code. Okay, so let's get started. So what is PEDAC? So PEDAC is a problem-solving process created by Launch School that helps especially beginners, I would say, become introduced to a systematic type of thinking that is useful for our code. Right? It's also designed to mitigate what's called hack and slash coding, which is kind of like when you're going headfirst into a problem and just diving first into a solution before really understanding the problem. And inevitably what happens is your solution often has gaping holes in it, and rather than taking a wider perspective and considering all the information about the problem that may have gone into that hole, we kind of patch things up here and there. Maybe that's not working. We maybe add a little method here, and it becomes this really hairy type of spaghetti code in which it hasn't really been thought out. And a common analogy that I really like to give is akin to that of like building a house. So if you think about when people build a house or any sort of building, no one just goes to the plot of land and just starts building the house, right? We actually, the idea of building the house starts years before the house is actually built, with architects, with engineers that have to figure out if is this plot of land suitable? What do we have to do to the plot of land beforehand? And even before they start touching the plot of land, they're designing a whole plan, right? And once we start building, we're not improvising things on the spot, we're sticking to that plan. So PEDAC process is really, we're creating an entire plan on how we're going to address this problem. And then really at the very end, the coding segment is us sticking to the plan, which isn't as sexy as it sounds, since a lot of the work is really happening in the first 4 steps of the PEDAC process, and the coding is really a small portion of it. But this is how we really dive deep into a problem and understand all the constraints and all the requirements that we have to meet. Okay, so I'll be making that house analogy often throughout this session today. So PEDAC, again, is an acronym, and it stands for the following. So P is problem, or more specifically, it's understanding the problem. Okay, and in this first step, we're doing exactly that. We're just taking the time to understand the full constraints of the problem, what it's asking of us to do. Okay, then we have examples and test cases, where we are going to be examining the examples and the test cases provided. Actually, I'm going to say examples / test cases. It's just an interchangeable term for the same thing. We're going to be checking the examples / test cases for any implicit requirements, and also to confirm our understanding of the problem is correct. We have the data structure, in which we have to determine what type of data structure our solution requires. We have the algorithm, which is a set of written out steps in which we describe how to get from the input to the output. And then C, the last step, which is code with intent. And specifically, intent is an important word there, because we're still going to be mindful, even though we're just translating our algorithm into code. Again, we're going to stay intentful with how we're going to code, and I'll be demonstrating that as well. Okay. I move on to the question. So I have a question right now, and I'll answer it. So somebody asked, where do edge cases fit in? The second step. So edge cases, that's a good question. So edge cases, the way that these problems are often structured is that you'll be given a problem statement, and then you'll be given a series of examples and test cases. And especially at the 101 and 110 level and the prep course level, you are not expected to create your own examples and test cases. You will simply be given all the examples and test cases. So sometimes there are edge cases. Most often there are edge cases in the test cases that are provided. And really edge cases, the way that edge cases fit into the PEDAC process is that we have to make sure in the problem that we understand what happens when those edge cases, if it's explicitly stated in the problem statement, how we handle those edge cases or cases that don't fit into the nature of our problem, then the problem step is where we're really trying to figure out, okay, like if let's say the input is part of an edge case, then does the problem statement tell me how to treat it? And if that's the case, then I should explicitly write that down, right? Because I should explicitly make note of that because that's how I have to treat that certain value. And then in the E step, in the examples test cases step, we're going to be examining the test cases and seeing, is there a certain way that the test cases are showing me that I have to treat the data, right? And then in your data structure and algorithm section, you have to make sure that your data structure and the algorithm that you create addresses that edge case. So we can see edge cases happening in the problem and the examples steps, and we have to make sure we address the edge cases in the data structure and the algorithm step. So it's kind of, and obviously in our coding step as well. So it's kind of everywhere, but we will see the edge cases likely in the examples and the test cases and sometimes in the problem step. Okay. It's a little abstract, I know right now, because I'm kind of talking about it in conceptually rather than through an example. But I hope I can maybe showcase an edge case. Yeah, I think I will be able to. So I'll kind of touch on that in just a moment. Okay, I hope that answers your question. Good question. Okay. Any other questions? Okay. So remember, PEDA is where we're really trying to process the problem and then and really digest the problem. And the coding with intent step is where we're actually solving the problem. Well, actually, what's happening is we're actually really solving the problem, the algorithm stuff, right? You should never go into the code with intent step being like, I don't really know how to solve this problem, but I'm going to figure out during while I'm coding, because that is what inevitably leads to hack and slash coding, right? Again, we're solving the problem in this step, in the algorithm and the data structure step, because they're kind of interrelated with each other. And then it's the code with intent step in which we're just translating our solution in plain written English into a coding language. Okay. Something that I will say is that it's really important to think of, especially the PED steps, as kind of investigative work. Try your best not to jump into solutions right off the bat, because and this is not just limited to coding, but this is a problem in the real world as well, is where we're all diving into solutions before we're really understanding the problem. In design, for example, whether it be user experience design or any sort of design, more than half of the workload goes into just investigating the problem and understanding the problem and making sure that we're addressing the right problem in our solution. So the same thing goes here. Make sure, if anything, maybe some more time should be dedicated to investigative work and the problem space instead of the solution space. Okay, so with that in mind, let's get started on our problem. Okay, so I'm going to give everyone a chance to read through this problem, and I'm also going to read it out myself. So the problem is multiples of 3 and 5. So the problem asks, write a function that computes the sum of all numbers between 1 and some other number, inclusive, that are multiples of 3 or 5. For instance, if the supplied number is 20, the result should be 98. And then it shows us the numbers between 1 and 20 that are multiples of 3 or 5 that sum up to 98, right? And then here we have a clause that says, you may assume that the number passed in is an integer greater than 1. Okay. So let's dive into the first step, and I can bring the problem back as many times as we need. So the first step, right? Understanding the problem. Okay, so there's a lot of information there, and I would say that these problem statements are often very, very carefully curated. So a lot of these words are usually really important, and because each word has often been catered very carefully, in order to outline the specific rules of this problem, it's important to read the problem statement thoroughly, right? We shouldn't be skimming it or just trying to find out the high details. We should be reading it really thoroughly, okay? This is also a good time when we're trying to understand the problem is to ask questions. If you have any questions or if there's something that you're not certain about, then this is the time to ask, right? Whether it be you're in an assessment situation at launch school or whether you're in an interview situation for a prospective job, it's important to ask questions if there's something you don't understand. I think students often think that asking questions is a bad thing because they may appear incompetent to their assessor or to their interviewer, but it's actually so much more of a red flag to an assessor or an interviewer if you're not asking questions and it's apparent you don't know something, right? Because that demonstrates to them how you'd be contributing to maybe a larger code base, for example. You're going to maybe have something that you don't understand, but instead of reaching out for help, you're going to make assumptions and simply power through, right? And nobody wants any assumptions that may affect the code in their code base. So don't be afraid to ask questions if there's something that you don't understand the problem statement, okay? So the way that we go on about understanding the problem is with 3 primary categories, which are the input, the output, and the rules, right? So why don't we start a little PEDAC process note section. So often what I do is I will have like a coding file, like a JavaScript file, and usually I create like a comment section at the very top. And I start writing my PEDAC notes here because then when I get to the coding part, I can just leave out the comment section and I can start, like writing JavaScript code and reference my notes. And this one, I'm just going to create a separate notes document that we can follow along together. All right, so the first step, understanding the problem. And as I mentioned, we have input, output, and the rules, right? So I'm going to go back to the problem statement. Based on this problem statement, what can we infer is the input, right? Oh, something I forgot to mention is that the general structure of these problems is that you're always going to be requested to write a function, right? So pretty much, let's assume that all of the problems that we'll be tackling and all the problems in the test bank at the launch school problem section all ask for a function. And that's also if you ever go to websites like Code Wars or like LeetCode, all those are specifically requesting for a function. So what, based on this problem statement, is the input of our function? Okay. So drop in the chat if you think you have the answer. What is the input of our function based on this problem statement? Right, so it's an integer above 1, right? So we have, in this section of the problem, it says, write a function that computes the sum of all numbers between 1 and some other number, inclusive, that are multiples of 3 or 5. So if the supplied number is 20, so this is the some other number in this example that they're providing, if the supplied number is 20, then the result should be this. And so we can gather from that statement that it's a number, our input is a number. But actually we have this other clause that's really helpful to us that says, you may assume that this number passed in is an integer greater than 1, right? So it's not going to be a decimal, right? If when we just say numbers in a broad sense, we can also include decimals and negative numbers. But because this clause tells us we can assume that the number passed in will be an integer, so it'll be a whole number, and it'll be greater than 1, so it can't be negative, right? So that helps us narrow down things a lot. So let's write that down. The input is going to be an integer. So I'm going to write a number, integer above 1. Above 1. Okay. Right. What about our output? What do we think the output of our function should be, and according to this problem statement here? Right, the number, the sum, right? Write a function that computes the sum of all numbers between 1 and the inputs, inclusive, that are multiples of 3 or 5, right? So in another example, if the supply number is 20, our result should be 98. So as a result, we have another number, right? So we have another number, and maybe we can write some more details here as well. That it's going to be sum of multiples of 3 and 5 between 1 and inputs. Okay. Right. Cool. So then, the next section, the rules. So rules is, I find the word rules might trip some people up, but maybe I'll expand it to also include additional details. So these are any additional details that would affect maybe how we go on about implementing the solution, or maybe there are constraints involved that really also kind of limit the scope of our solution as well. So maybe what are some important additional details that are mentioned in a problem statement, or some rules that we think might be important to keep note of? So any boundaries, any constraints, any details that are really useful, that we really need to keep a note for this process moving forward. I can see maybe definitely at least one really important note here that would affect how we approach the solution. Correct, inclusion. So we have write a function that computes the sum of all numbers between 1 and some other number inclusive. Inclusive is really important here, and the example they provide shows that, because the supply number is 20, and we can see in this expanded out sum of all the numbers that create 98, that 20 is included, right? Because we're including, it's inclusive of the supply number, right? So that's really important to note. Oops. So because if we didn't have that inclusive clause, the sum would be entirely different because it wouldn't have the input number and we would have 20 less there, right? So that's a really important note that's going to affect and shape our implementation. So the input number is inclusive towards the sum. Right? Only multiples of 3 and 5 added to the sum. That's an important note. So I ended up writing it here, but it really doesn't matter where you put it as long as you put it somewhere, right? So only sum of only multiples of 3 and 5 are counted towards the sum. I would say even if you think it's obvious, if you need to write it down, then like there's no points lost for redundancy there, right? You're just really drilling home the important things that you want to keep in mind for the problem. So I don't think there's any fault in that. So I would say that in this case, multiples is quite a universal word, but you know, it's maybe some of us didn't take arithmetic math, or maybe as for some of us, namely myself, it's been maybe 10 years since you've taken a math class. So maybe you're asking yourself, well, what is a multiple? Or maybe in the context of certain problems, multiple can mean a different thing, right? So if it's not super apparent to you what a multiple is, like that's also a question you can ask, or that's like a detail you can write. What counts as a multiple? Right? Again, the definition of a multiple like might be obvious to us, but also maybe that changes in the context of a problem. Maybe it's like a special problem where they're saying multiple means something else. I think based on this example that they provided in the problem statement, we can infer that a multiple means that it's a number when divided by 3 or 5 is remainder 0, right? So we can maybe add that definition as well. So number can be divided by 3 or 5 without remainder, right? Okay, nice. So I think that's pretty much it. We can start moving on. Great work, everybody. Okay, so let's see. Okay, let's move on to the next step. So the next step is the examples and test cases, right? So these are the examples and test cases provided for our problem statement. And as you can see, there are a list of function invocations. So as I mentioned before, with these problems, you're almost always expected to create a function. So based on the fact that they've provided us with a function invocation and a value, we should assume that they want us to, or not assume, we know that in this case that they want us to create a function named multisum, and then this is the input that they pass into the function. And this commented out section over here is going to be the expected output. So when I create the function, my job as the person trying to come up with a solution is to write the function body, right? So I have to write the function body in such a way that when the input is 3, the output is also 3. When the input is 5, the output is 8, and so on and so forth. And the way that our function is supposed to be created is by the thing that we need to do with our function is to create a function that creates this input or produces this output based on a certain input, right? So here's our example and test cases. So I'm actually just going to paste these into a JavaScript file that we'll be working on later. So let's do fetch PEDAC.js and open it file up. And I'm going to just paste that in here. So you can see Cloud9 is complaining to me because we haven't created the function, which we will do when we get to the coding step. Right, so as you can see in this JavaScript file, the commented out section with the double slashes means that we can freely write comments here and it won't affect our code. And the comments have showed us what the expected output should be. Right, so now that we're at the examples and test cases step, really the step is actually still an extension of understanding the problem, to be honest, because what we're still doing here is we're still trying to understand the problem. And how we're doing so is we're going to be looking at the test cases, so some examples of input and output, and we're doing two things, right? So one is to validate our understanding of the problem. So everything that we've written so far here, our input, output, and the additional details in the rules, we're simply checking the examples and test cases to ensure that our understanding of the problem so far is correct, right? So why don't we do that right now? Let's take a look at the test cases and let's look at our what we've written down for understanding the problem and make sure we're on track. So the input we've written is an integer above 1, and the test cases do confirm that is the case. They're all integers above 1. The number, the output is the number, and it's going to be the sum of multiples of 3 and 5 between 1 and the input. So I have from 1 to 3, 3 inclusive, only 3 is a multiple, right? Between 1 and 5, the numbers 1 and 5, 1, 2, 3, 4, 5. So 3 plus 5 is going to be 8, right? That's correct. So maybe this one requires a little bit more fleshing out. So we have 1, 2, 3 plus 4, 5 plus 6 plus 7, 8, 9 plus 10, I believe, if I do that math. 5 plus 6 plus 9 plus 10. Yeah, that's correct, right? So it is only the multiples of 3 and 5, and it seems like we have the right understanding of the word inclusive, we have the right understanding of the word multiple, right? Because all the test cases are coming out to the correct answer. I'm not obviously going to break that 1001 right now. We're just going to have to see when our code runs if that's going to be addressed. But so far for the first 3 test cases, it seems like we have a really solid understanding of the problem, right? Number can be divided, right? So back to that question about edge cases, right? So I would say here, edge cases are called edge cases because usually where an often overlooked area is when the number is on the very small end of the spectrum that we're addressing, or the value is on the very minimal or on the smaller end of the spectrum of values that we're trying to address, or it's on the very high section. So we have a very high section here, and that's 1,000, and it seems like we still get an appropriate value. I would say 3 is almost like an edge case, because it's saying we're getting the inputs. This is kind of addressing the problem of what happens when there is only one multiple, right? Because I only have one multiple, I can't add it to anything else. So like, do I still return just that multiple? And the answer seems to be it's yes. So when there's only one multiple, basically between the input, between 1 and the input, we're still using that single multiple to count towards a sum, right? So I'll say this is kind of an example of an edge case. But again, edge cases we're examining through the example/test cases provided. You are not expected to generate edge cases or come up with test cases that are not listed here, especially in early stages of the prep course and 101, 110, 109, etc. And for most often of these like LeetCode, Code Wars problems as well, you are not expected to generate your own test cases, right? This problem has been designed to stay within a certain confine, and that's why these are the test cases that are provided. And so I would say some students say, oh, but like shouldn't I do input validation? Shouldn't I do XYZ? And I'm going to say, if it's not listed in the problem statement at this stage, don't go beyond what the problem statement has requested you to do. Okay. So we've confirmed that our understanding of the problem is correct. And what was part 2 of what we have to do? So for the examples and test cases step, our first step was to validate. We look at the examples provided, and we're, number 1, validating our understanding of the problem, right? And we've done that. We checked our input, output, and our rules/additional details are pretty much on par with the examples provided. The second point of this step is by looking at the examples, we may derive implicit requirements, if any. This is really important, if any. So let's go back to our examples, right? So based on this one, so if I had to really seek for an implicit requirement, I would say maybe that first edge case was 1, because our input is 3 and our output is 3. So it seems like only one number would count towards the sum. So when I don't have another number to add it against, do I still count it towards a sum? And the answer is yes. So the implicit requirement is maybe if I'm really pushing it, to be honest, that when there's only one multiple, then only that multiple is counting towards the sum, right? So maybe another example of an implicit requirement would be, and you don't have to write this, like, in fact, don't write this down, but let's say I wrote something like this, or, right, let's do something like that. And the expected output is the string invalid because the test it's not the correct prim and value type for this problem. So what we're looking for, what an implicit requirement is when there's a requirement that we can see in the test cases that is implied, hence implicit. It wasn't explicitly stated in the problem statement. It said something like, we may assume that the number passed in is an integer greater than 1. It didn't say that if there's a string or an invalid data type that is passed into the function, return the string invalid. It didn't explicitly say that. We had to derive that from the test cases, right? There's a test case here that shows when it's not or in this case, it's just a string. Well, it's not an integer data type that's been passed in. We have to return the string invalid. So then that would be maybe a requirement that we write in our additional rule section. If input is not number, then return string invalid, right? That would be an example of an implied requirement because it was not explicitly stated in the problem statement. However, as I mentioned, that's not the case here, right? That's why I'm saying, if any implicit requirements, then we should derive those from the examples and test cases. And you know, if you really look at it for a long time and you really don't see any implicit requirements, I'd say, you know, it's time to move on. I think a lot of students get really concerned here and they kind of overfixate on this step, thinking that, like, oh no, like I can't see anything, and maybe I'm not getting it, but sometimes it just means that there aren't any implicit requirements here. Okay, so for this problem, I'd say maybe, yeah, I wouldn't really consider any implied requirements are really derivable from this step. Okay, so that's examples, test cases. Any questions so far before we move on? Okay, cool. Next step. So P and E down, we have the next step, the data structure step. So D, right? So especially earlier on, there's plenty of data structures out there, and that's a lot more advanced. But at launch school, we're only focused on the fundamentals because data structures are something that, takes years to master, right? And we're looking at mastery in launch school. So what we've limited the scope to is simply an array or an object. So when you're in the courses 101, 110, and the prep course, the only thing you have to ask yourself in this step, in the data structure step, is do I need an array or an object to house our data? But you might have noticed something a little jarring at this step. So we just dedicated the entire first two steps of P and E to just, investigating the problem, really understanding what we have to do. And then suddenly we jumped to this D step that was like, okay, so does your solution need an array or an object? And personally in my head, I'm like, solution, I just broke down the problem and now you're asking me about my solution. And first of all, you're asking me if I need an array or object for my solution. Like I haven't thought that far yet. So I'm gonna say nix this for now. In between the E and the D steps, I like to think, I like to pause. I call this the mental model intermission. So I pause to think of a mental model. And this is really just this is a step you should take just to ask yourself, like, okay, do I know what the problem requires us to do to get from the input to output? Like, do I know how I'm going to get from the input to output in a general sense, at the very least, right? And this can be something like, okay, am I going to have to, I'm going to clearly have to find the sum. I'm going to first have to find like all the multiples between one and the input, right? And then I'm going to somehow have to figure out how the numbers between that number range. I'm going to have to somehow pick up the multiples of 3 and 5 in that number range, right? So in my mind, is it I might have to, as someone like me where I've been exposed to a lot of problems, I can think right off the bat. It's like, okay, I know I'm going to iterate between one and the input number to find all the multiples, or maybe there's some discernible pattern between the jump range, the gaps in between the numbers that I need, right? So maybe I have that idea in my head, but if you don't have a mental model, just because you haven't been maybe exposed to as many problems, I'm going to say this is the time to develop that mental model before you move on, right? As I said, the next question is already asking you about details of your solution. So if you don't really know how to approach the solution so far, then I would say a really good exercise to do is to compare the input, the output, and to bridge the gap in between, okay? Let me demonstrate what that looks like. So let's take a look here. So I'm going to write mental model development. Okay. So we're going to compare the input and the outputs. So let's get I believe the input was 20 and then the output was 98, right? For the example that they provided. Okay, actually, let's work with a smaller example. So let's do from 10 and 33. Okay. So if the input is 10 and the output is 33, and let's say I don't have a mental model. I stated one earlier where, like I'm gonna have to iterate through the numbers between 1 and 10 and then like sift out the multiples of 3 and 5. But let's say that's not super obvious to me, because you'll definitely run into problems where you will not be able to gauge a mental model just from looking at the problem, just from the first steps. So a really good way to develop one, again, is to look at the input and output. And what I do is called bridging the gap in between. And this is because this input to this output is really jarring. It's very binary. It's either on or off. It's input output, right? There's no gradation or graduality in the steps in between. So what I do to start thinking of a mental model is I start trying to fill in the gaps in between of what's going to happen in order for me to get from input to output. And the great thing is I can start from the input or I can start from the output, or I can do both as long as we meet in some middle, right? So maybe I can start with, I know we're starting from number 1 to 10, right? So maybe 1, but 1 wouldn't be counted towards a sum because it's not a multiple of 3 or 5. So I know from 1 to 10, the first multiple is going to be 3, and then 4, and then 5. So 5 is a multiple of 5, and then 3, 5, 6, 6. And then basically I'm just kind of trying to break down what numbers are going to be included towards 33. So 7, 8, 9. And then remember 10 is inclusive. So it's going to be, 10 is also going to be there as well, right? So can we see that we've now kind of created this gradation in between of numbers that will lead up to 33 eventually. The catch is that we're going to have to add all of these together. So we know that because it's going to be a sum. And now I'm kind of getting like, instead of just white and black, I'm kind of getting all the grays in between. And the great thing about this is that now I can kind of piece down what I might have to do in order to get to that final result. So again, try and treat this step as investigative work. Try not to think of solutions yet, because I think it really clouds your ability to derive patterns. So just treat it as you're really just trying to get to know what's happening here. So maybe the first thing I might do is maybe go like, okay, is there a pattern in between these numbers? Maybe I can write an algorithm in which it like jumps in between. So the difference between 3 and 5 is 2. The difference between 5 and 6 is 1. Okay, so 2, 1, and then the difference between 6 and 9 is 3. So it's like 2, 1, 3, and then 1. So to me, there's not really like a pattern here. Okay, so if there's no pattern, it means that I might just have to, go by each digit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I might just have to sift out maybe based on some condition. So now it's like, it looks like because I'm going through every number between 1 and 10, I'm iterating, right? I'm just iterating through all the values. And then based on a certain condition, I'm picking out the ones that are going to count towards my sum, right? And so I've pretty much developed my mental model then, right? My general mental model, this high level what I have to do to get from input to output is iterate through the numbers from 1 to input and count multiples of 3 and 5 towards the sum, right? I couldn't discern any sort of pattern in between the multiples. So then I think what I have to do is iterate through all of them and count only certain numbers towards the sum, right? The really great thing about this mental model development is that we can just see right here, like kind of exactly like what we have to do, the milestones that we have to hit in our code, right? I might have to sift through some of these values, and then I just have to make sure I really cherry pick the ones that I want. The thing is, there can be also multiple approaches and multiple mental models for any sort of problem, right? There's never just one way to approach a problem. So for me, I'm more comfortable with numbers and number and string iteration. I try to avoid arrays as much as possible unless I really, really need a specific thing about an array. But sometimes people's mental models may lean towards arrays. So I have, maybe for me, my natural mental model, and remember, actually, the most important thing is that you go towards a mental model that it comes most naturally to you. Okay, don't try to go for the mental model that is most efficient or most runtime, like has the fastest runtime or whatever. We're not looking at efficiency here. Optimization is something that takes years of practice and quite frankly, often rarely makes a difference. So what we're looking for is the mental model that comes naturally to you. So maybe someone that is more inclined towards arrays would see this problem and go like, okay, I would maybe generate an array of the numbers between 1 and the inputs, right? And then I might do something like only maybe iterate through the numbers in the array so that only the multiples that I want remain in the array, right? And then I find the sum of the array and then I return the sum, right? So iterate through the numbers from 1 to input and place them in an array. Then keep only the multiples of 3 and 5. Then find the sum. Right, so I have two different mental models here. Right, so for these problems, you're only expected to create one. You only really need one, but I'm demonstrating how maybe people have different ideas, and every idea is not necessarily every idea is not wrong or is fine, but you know, some ideas are obviously better than others. But again, there might be different approaches to the same problem. Okay, so another really great thing about this whole like input to output gradation method is that now when I get to the next step, the data structure step, when I'm asking myself, do I need an array or an object to house my data for my solution? Then when I look at my whole gradation thing and the whole like steps and the milestones I have to reach in my code, I can just look at this and I can ask myself like, oh, like, is there data? Is there an array or an object that I need? So for my first mental model, I only see numbers. I don't necessarily need an array or an object. So for my first mental model, I'm going to say I don't need an array or an object. I'm going to need like, you know, some sort of variable that's going to hold the sum, right? As I'm iterating, I need to hold this, maybe like a number somewhere. Maybe it starts at 0 and then I'm only going to add, as I pass through all the numbers, I'm only going to add the multiples of 3 and 5 to that number. But I don't need an array or an object. But when I look at mental model number 2, again, this whole like input to output gradation thing just shows me right off the bat, like, am I going to need an array for my solution or to hold any data in my solution? And the answer for my second mental model is yes. Data structure, array to hold the multiples, right? For this one, data structure, NA, right? I don't necessarily need an array or object. Okay. Sometimes I get students who ask me if strings or numbers are considered a data structure. And I would say sometimes, like, the thing about JavaScript strings especially is that they're iterable, as in each letter and each character has an index, which is not really common in other languages. So I can maybe sometimes we'll consider a string a data structure as well, but you want to be careful of that because we should still treat strings as primitive values. But you know, sometimes if you need a string to hold some characters, then I wouldn't dock points if someone told me, oh, like I'm going to use a string to maybe hold this. Likewise, if someone told me I'm going to use a number like a variable with the number 0 to hold the sum, like I wouldn't say that's wrong per se. But remember that this step per se specifically is asking, do we need an array or an object, right? So again, mental model number 2 requires an array, mental model number 1, not so much. Okay, easy. That's the only thing that this step is asking. So then we get to one of the most challenging parts of PEDAC, right? The algorithm. So remember that we're doing all these steps one by one. We're not doing them simultaneously. So the next step here is algorithm. And what the algorithm is a series of steps that details how to get from the input to output. How, right? So you might be asking, wait, Grace, didn't we do that in the mental model step? Like, isn't this entire line like, or this whole mental model created? Isn't that the algorithm? And there's a difference between the mental model and the algorithm, because what the mental model is a general what we have to do, right? I have to iterate through the numbers from 1 to input and count the multiples of 3 and 5 towards a sum. That's a high level what. It's like, oh, like, what do you have to do today? And I would say something like, I have to go to the grocery store. But if someone asks me, okay, how are you going to do that though? If someone asks me how I'm going to the grocery store, then I have to start breaking down like everything. I'm going to say something like, okay, like at 8 o'clock, I'm going to get dressed. And then at 8:15, if I've got dressed quickly enough, I'm going to walk out the door and then I'm going to go down the stairs. Then I'm going to walk down the street, right? These are actual like implementable steps. Whereas for this broad what statement, I can't translate this into code. A good question for you to ask is, can I translate that directly into code? Like, can I translate this statement directly into code? And if the answer is no, then it's not specific enough. Okay. So the algorithm, series of steps that details how. There's a difference between the how and the what. The mental model is the what, the algorithm is the how. And really the hardest part about the algorithm is getting the right level of detail, because, right, you have to be specific enough in that you can translate it directly into code. But one thing that you have to be careful of is that we want to keep it general enough so that it's language agnostic. Okay. So what that means, so specific, so right, the challenge is the right level of detail, high level enough, so broad enough so that it's language agnostic, but specific enough to implement, specific enough to translate it into code, but it can't be, you want to keep it language agnostic, which this means that you should not be naming specific syntax or specific methods. So instead of saying, let's go down here, algorithm. So instead of saying something like use the for loop or use the for each method to iterate, or so you shouldn't be saying things like use the for loop or use the for each method. And this is because you don't want to marry yourself to a specific way of doing things, because as we know in JavaScript, there's like various, like dozens of ways to do the exact same thing. So in this case, we're trying to iterate through a series of numbers, right? So I could use a for loop or I could use a for each method. We don't want to write things like that. We want to write something like iterate through the values, right? The reason for this is because you may find that once you're translating your solution to code, that maybe a specific method doesn't work. For example, if I'm using the for each, if I married myself to the for each method, and then I'm using the for each method here, and then as we all know, the for each method does not return a value. Its value is undefined, right? And then you're like, oh, like actually, like I wanted to create a new array, so like maybe the for each method didn't work. But because your algorithm specifically wrote the for each method, it's a lot harder to zoom out and figure out what you need to know, or what method might be more appropriate here. Whereas if you simply wrote iterate through the values or iterate through the array, then I can be like, okay, the for each method didn't work here. And it's easier for you to keep high level and then zoom in and jump into different ideas. Whereas if you're already glued to an idea, it's actually a lot harder mentally to zoom out and maybe think of other prospects. So keep it, again, specific enough in which you can implement it, but don't marry yourself to specific syntax and specific methods. Okay. So I have a question here. The algorithm is like pseudocode. The algorithm is exactly pseudocode. That's the section that we're kind of writing here. I should actually write that. It's pretty much pseudocode. Thank you. I'll adjust the slides next time. So the series of steps that details how to get from input to output. So it is writing pseudocode, but with these specific requirements in mind. So don't write specifics, language, syntax, or methods, right? So the way you know that you're doing this correctly is that you should be able to give your algorithm to someone in Launch School's Ruby track, and they should be able to code out a working solution in Ruby, right? Your algorithm should be language agnostic. Okay, so that's our algorithm. Let's start writing one. So the great thing about this whole like input to output gradation thing is also that I can simply just reference this. So let's let's write an algorithm for our first mental model. The great thing about this whole input to output gradation approach is that it shows me exactly what I have to do in the algorithm, right? So I can see I have the numbers 1 to 10. So I know how to iterate from the numbers between 1 and the inputs. So maybe my mental model, so I'm just gonna write number 1. Maybe my number 1 algorithm is something like, okay, iterate through the numbers between 1 and the input number, inclusive. Super important, inclusive, right? So because 10 is included. If we don't iterate through all the numbers, including the input number, we're not going to get this counted towards our sum. So remember that it's inclusive. Actually, something that I neglected to do is that because I'm going to be iterating through each of these values, so let me write that down. So I'm going to iterate through the numbers between 1 and the input number inclusive. If the current number that we're iterating on is a multiple of 3 or 5, then count it towards the sum. But how do I count it towards the sum? So now I know that before I start iterating, I need to maybe initialize, I need to declare a variable that's going to hold that sum. So maybe I can write something like declare maybe the variable sum and initialize it to 0. Right? Because it's going to start at 0. I don't want any other numbers to be counted towards the sum, so I want to start it at 0. So that means here, within my iteration, I can say, if the current number is a multiple of 3 or 5, then count it towards the variable sum. Return, and then once it's finished iterating, so I nest things like this, so I can show that when it's iterating, but you can write something like, once iteration is finished, return the sum, return sum. Okay. There is one thing here that is a little lacking, and that's this clause. If the current number is a multiple of 3 or 5, then count it towards the sum. But notice how I didn't get stuck there. I just kind of wrote it down and then I moved on. It's better to get the all the scaffolding in place. And if there's something that needs additional detail, it's easier to come back to it afterwards. So I don't think I can translate this directly into code. A multiple of 3 or 5. So like that's there's like no, I can't think of code in my head right now that's going to kind of get that down. But remember what we said, what multiples are. They are numbers that can be divided by 3 or 5 without remainder. So that's something I can check, right? So if the current number is a multiple of 3 or 5, so if the current number divided by 3 or 5 has a 0 remainder, right? Because that is one way that we can check if something is a multiple or not. Then count it towards a sum. And I think this is translatable into code. And this is not, you might be all be thinking that, oh, there's clearly a specific operator you're thinking of here. And I would say it's true. I think this operation is maybe a little code specific, but it's pretty language agnostic. Like the remainder operator is available throughout like almost all languages. You can think of it as like addition or subtraction. So I would say in this case, I wouldn't flag it be like, oh, like you're not being code agnostic. Okay. So let's try writing an algorithm for mental model number 2. So again, the great thing about this approach of input to output gradation and creating a mental model that way is I can just simply paste it here for my algorithm. And number 2. And then I can simply write an algorithm here. So in order to create this array, I'm first going to need to create an empty array that's going to hold the values, right? So notice that anything I write previously in my whole PEDAC document, it's not fixed in stone. Like I can go around and edit it. And in fact, like I almost encourage like a circular approach. Maybe like you don't have to get it right perfectly. You can bounce back and you can edit things, right? Don't be afraid to, maybe if you feel like you caught something or you missed something, like I missed that empty array initialization, you can go back and edit things, right? So based on this mental model, I'm going to say declare an array, declare multiples and set it to an empty array, right? I'm going to iterate through the numbers from 1 to input inclusive and add them to the array, right? Iterate, sorry, I'm like typing what I say. Iterate through the array, iterate through multiples. Sorry, so I should refer to the array here as multiples as well. Iterate through multiples and keep only the values with the multiple with numbers that when divided by 3 or 5 return have a remainder of 0, right? Find the sum of multiples, or return the sum of multiples. Right? So we have, again, there's no specific methods that are being named here. But I would say that this is like just the right level of detail in which I can implement into code. I can translate it directly into code. Okay. So any questions so far on the algorithm? I would say the algorithm is probably the trickiest part, next to obviously maybe figuring out how to do it. And that's because I don't think this is a skill that we naturally practice regularly, right? Again, having this input to output gradation is really helpful because then I'm just describing how to get from this step to this step to this step to this step, right? If I have it fleshed out like that. And some of you might just have this mental model in your head, hence why it's called mental model. For me, I find it really helpful to write it down, and that way I can have it tangibly there when I need to write my algorithm. But again, everyone has maybe a different approach to it. Okay, so finally, we have arrived at our final step, which is to code with intent, right? Code with intent. So the important thing here, as I mentioned before, well, the first thing is, this is the most important rule, I think. Personally, I think this is really the most important rule. And the most important rule is to run your code often. The absolute last thing you want to do is write out your entire function and then only run it at the end, and then the output is not what you expect, and you're like, okay, I have no idea where this bug is happening, right? You want to maybe every couple of lines just like run it, see that it's doing the thing that you want it to do. Maybe you should like definitely make use of console.log. Don't think that, oh, like I should only run it towards the end because otherwise like my interviewer is going to think that like I'm incompetent. It's no, just run it as many times as you want. I'm not going to like, I would never, or it's really unrealistic to think that you know, this is still part of your process. Like you're figuring things out, and this also happens in real life, right? Like we run into unexpected things, and maybe you're not quite, I would say like I'm pretty confident that this algorithm is going to work. And if as long as you feel really confident, like move forward with the code. If you're feeling like, I don't think that's gonna work, like, and you want to move forward to the code already, I would suggest avoiding that. But if you're pretty confident in this, the truth is like even as much as I am confident that this is going to work, I don't know until I code. So it's okay if as long as you tried your best and you feel pretty confident in it, and you can ask yourself like, is this all implementable in code? Is it language agnostic? Then that's what's the most important thing, and you should move forward, right? Run your code often. Don't be afraid for it to be incorrect, because this is where we have to make sure we check that each step of the way is working as we expected it, right? Make sure that you run it each step of the way, and you know, don't be afraid to face the fact that it might not be quite right all the time. Okay. Also, really important, as we talked about our house analogy, right? You don't see the construction people as they're building the house. They're like, oh, like, you know what? I feel like I want to add this new accessory to this house because like I just feel like it. Remember that the people who are building the house stick to the plan as closely as possible. That plan is millions of dollars invested into it. Our plan has we've developed this over the course of an hour. We want to stick to it, right? Because this is where we solve the problem. We're not solving the problem in the code step. We already solved the problem. This is simply just translating it into another language, right? This goes back to what I said before. If something doesn't work, do not panic, right? Simply what you have to do is stop coding, because again, we're not solving the problem in the coding step. Go back to your algorithm and then figure out what happened. You should be sticking to your algorithm as close as possible, because that's where, again, we solve the problem. So really you wanna stick your code to as close to the algorithm as possible. So if something doesn't work, it doesn't mean you should start coding, and then that way you're gonna end up straying pretty far from your algorithm, which is the place where we kind of factored in all of the things we need to know about the problem. So that means you should stop coding, go back to the algorithm, figure out what went wrong there, and then go back to your code. Okay? So let's finally get to coding. I'm gonna take the first one here. Let's do the first mental model. This is my JavaScript file. As I mentioned before, I usually put all my PEDAC information at the top in this commented out section. And that way I can reference it while I'm coding instead of switching between windows. So there's my algorithm. Remember that for the function, we have to create it first. In order to call a function, we have to define it. So I'm going to declare the function multi-sum because that's what we're expected to call it. I'm going to call it the parameter. Remember, there's one parameter. There's an input. So I'm going to call it num. And so, yeah, let's code out our algorithm. So first line, declare sum and initialize it to 0. So I'm going to declare with the let keyword because I'm probably going to have to reassign it a bunch of times since I'm creating a sum. So let sum equal to 0, right? Next line, iterate through the numbers between 1 and the input number inclusive. Okay, so there's many ways. I could use a while loop, I could use a for loop. I'm going to use a for loop. So for, that means I'm going to have an index. And if I wanted to iterate through 1 and the input number, then I'm going to have to do let count is equal to 1 because it's starting at 1 and keep running this loop because I need to iterate between 1 and the input number exclusive. So as long as count is less than or equal to num, because I still want it to run when it's equal, keep running the loop, and I want count to be iterated by 1 because I want to go through all the numbers between 1 to 10. Right, so iterate through the numbers. If the current number, when divided by 10, when divided by 3 or 5 has a 0 remainder, then count it towards the sum. So I know about the remainder operator. If current number, so current number is count, if count, the current number is count. If count divided by 3 has a remainder of 0, so remainder 3 is equal to 0, or count remainder 5 is equal to 0, then count it towards a sum. So that means I need to count has to be added to the sum, right? So I'm actually going to stop here. What I should have actually done was stopped earlier than that. I got a little carried away. So we're going to pretend that this didn't happen. And what I want to actually do first, do as I say and not as I do. So what I should have actually done here is I should have just checked to make sure that this is producing the numbers that I wanted to, making sure that this is iterating through the correct numbers, and making sure my loop is just working in order, right? So I'm just gonna pretend that didn't happen, and I'm gonna log the value of count first. So I'm going to run the file. Actually, and before I do that, I'm going to comment out this huge test case because otherwise I'm going to get the numbers 1 to 1,000 logged. So I'm going to just run the file. And what I'm expecting right now is that I'm getting all the numbers from 1 to the input number logged to the console. So we can see for the first test case, I got 1, 2, 3. The second test case, I got 1, 2, 3, 4, up to 5. Yep, that's correct. And then for the last test case, I got from the numbers 1 to 10. So my loop is iterating as I expected. Okay. So if count modulo 3, pardon, that's not modulo, that's remainder. So now let's pretend I did that and I moved on to the next part of my algorithm. So if the current number when divided by 3 or 5 has a 0 remainder, then count it towards the sum. So first I just want to make sure that this is flagging all the correct numbers. So again, I'm going to log the value of count here as well. And we should get the same result except only the multiples of 3 and 5 for each test case. So the first one I can see I only got the 3, that's correct. The next case I can see I got 3 and 5, yep, and that makes 8. For the third case, we can see that I got 3, 5, 6, 9, and 10, which, as we've broken down before, is the correct numbers. Awesome. So that means I can start moving on. If the current number when divided counted towards the sum, so sum is plus equal to the count, right? And then once iteration is finished, return sum. So let's see. Let's first log the value of sum, because we know that when we return it, otherwise I'm going to have to console.log all these statements as well in order to see if I'm right. So I can just maybe write it here to see I have the correct value. So let's run it again. And we can see we have the correct answers. We have 3, 8, 33, and 2, 3, 4, 1, 6, 8. Right? Awesome. So that's the first mental model. Let's do another one, or let's do the other mental model that we have. And this time I will test my code frequently. So let's paste that in. And let me just wrap lines. Okay. So again, let's do that process all over again. So here I have function multi-sum again with the num parameter. Okay, here, declare multiples and set it to an empty array. Let multiples equals to empty array. Right? Iterate through the numbers from 1 to the inputs, inclusive, and add them to the multiples. So I'm going to do, maybe I should demonstrate a while loop. So honestly, for loops come a lot more naturally to me. So let's do a for loop again. For, similar to before, I'm going to, so iterate through numbers from 1 to input inclusive. So let count equal to 1 from 1, and count, keep running until count is number, count plus equal to 1. So I've intentionally made a bit of an error here. And I did what was, I didn't factor in the inclusivity. Okay, I didn't follow my algorithm to the T. Maybe I was just like too super focused and I just kind of overlooked it. And this is why it's really important to test your code frequently, right? So why don't I try logging the value of count right now? Like, let's say I'm someone who I made that mistake, but at least I'm testing my code frequently. So what happens then if I just tested my code now here? PEDAC2.js. And I can see right here that we're missing a value. If I coded my entire solution out, or let's go back to the other one. Let's say I coded my entire solution and I had made that same mistake and I only ran my code at the end. So if I do node PEDAC.js and I log the sums, oops, console.log sum. If I log the sums now, 0, 3, 23, and all that, right? Okay, I can see that my answer is wrong, but the issue with this is because I coded out my entire solution without stopping in between to test my code frequently, I don't know where this bug is coming from. I have to look here, I have to look here, and maybe something is wrong with the requirement here, maybe here, or maybe I like botched something over here, right? This is why it's part of a huge part of debugging, and one of the hardest things about debugging is actually isolating the problem, figuring out where it's coming from. If I test my code frequently, then I know that, for example, if I tested it over here, then I know it's only coming from it's definitely not coming from the initialization because the initialization is 0. So that means there's something wrong with my for loop, right? I can isolate the problem right in that section alone, right? So that's why it's super important to test your code often. So I tested my code here and I realized I didn't include the input number. Iterate through the numbers from 1 to input inclusive, add them to multiples. So I know one method to add an element to an array is the push method. So I'm going to push count. And then after array iteration finishes, let me just see, I have all the numbers that I want in my array. So node PEDAC-2.js. So yep, I got all the numbers. Right, so then next one, iterate through multiples and keep only the values with numbers that when divided by 3 or 5 have a remainder of 0. So I know a lot of approaches that can take this. So maybe it's going to be, I can do the for each method. I can use, I can just, again, use another for loop. But I think something that fits as well is the filter method. I'm sure a lot of you were thinking. So I'm going to reassign. Remember that filter returns a new array. So I have to reassign multiples to be the result of the filter method called onto multiples. So return elements, keep elements in the filter method in the new array that when are divided by 3 have a remainder of 0, or divided by 5 have a remainder of 0, right? So let's just check that again. Console.log multiples to see if I have the right ones. And as we stated before, we do have the correct ones, right? Return the sum of multiples. So again, I'm going to have to iterate through multiples in order to accumulate all the numbers into a sum, but I can use a for each again. Maybe I can initialize the variable to 0, and then I can use for each to iterate through all the array elements and then add the current number to the sum. But again, I'm pretty comfortable with array methods. So another array method that I want to use is the reduce method. So reduce takes a callback function with 2 parameters, and we're going to do ac plus val, and the starting number is going to be 0. Let's check if that works. And again, that's the correct output that I'm producing. So then I'm going to return the value of sum. And now let's log our final results and also return it. And we can see that it's the correct answer, 3833 234168. Okay. So again, remember that this algorithm that I've written, it's also friendly for everyone. Like I used the reduce method because I'm more familiar with the reduce method and the filter method as well, but maybe some other people aren't. Maybe whoever you gave this to in Ruby, and maybe they don't have a reduce method. I personally don't know. I don't know Ruby. But what's important is that they can just use basic loops and basic syntax in order to implement this. We don't have to be all complex with these different methods. And that's why I really ask that it's really important that you don't start with methods in your head. Don't write the algorithm thinking about methods. Just simply think about purely what you have to do. If you've created this gradation mental model, just look at it and ask yourself what you have to do to get from this to there. Don't think about, okay, I'm going to have to use to get to this array, I'm going to have to use the filter method. Simply think about it as I'm iterating and only selecting the specific elements that I want, right? That way it's a lot easier for you to bounce back. Maybe you were coding and maybe you messed up the callback function to the filter method. Maybe you're not so comfortable with callback functions. Again, go with the approach that makes the most sense to you and is most natural to you and things that you're the strongest in. You don't want to go into an interview or an assessment with concepts that you're not really strong with, or you're fuzzy, or you don't want to whip up regex or regular expressions because they're more impressive, right? Go with the things that you know. Okay. Okay. So that took forever, right? I'm not even going to sugarcoat it. That took a really long time, and at first PEDAC is a really taxing process, and it's just because you have to shift your mind to really slow down and to really process the problem before you go on about approaching it. And I'm going to say that it's only like that in the beginning. If you keep working towards it and if you keep practicing, you can really cut this process down to just a couple minutes, while retaining the level of detail that you need in order to still solve the problem. Okay, so I have a couple takeaways here. So really important tips, I guess, that I think are the most applicable after teaching PEDAC for so long. And number one is that we fall to the level of our training and not to the level of our expectations. So I often run into students where they see a lot of easy problems and they're like, I don't need PEDAC for this. And they kind of just go like, okay, I'm going to use PEDAC when the problem gets hard. I'm not going to do it now. And the thing I recommend to that is to use PEDAC even for the smaller problems, because you want to practice that way of thinking. So if you only practice that way of thinking for the hard things, if you can't even do it for the small things, you won't be able to do it for the hard things. At least it'll be really difficult for you. What's really important in the beginning is focusing on process. It's not about focusing on the end result and seeing that you got it right. Because remember, we're not trying to fall into hack and slash coding here. We want maintainable, clean code. So that's why this process is really important. If you practice on the smaller ones, when you get to the bigger ones, it's a lot easier to just execute, and it's more of like you don't have to think about it too much, right? So that being said, it does get easier and faster. It's only like that really in the beginning. It's that really challenging rule in the beginning. It doesn't have to be perfect. Again, you saw me, I slipped up a little bit too, and I bounced around, and that's totally fine. Whatever you wrote in the beginning doesn't have to be set in stone. Maybe just later down the road, you're like, oh wait, there's like this requirement I just realized while I was coding. Then just go back to your problem section and factor that in, and maybe you will have to like go through the steps a little bit again, but that is totally fine. Um, there's no like wrong in slipping up a little bit or like having mistakes here and there, right? Process is a lot more important than the end results. That being said, struggle is not really a measure, it's not really a critique on your skill level. It's more of a measure of how many patterns you've been exposed to. As I often state, we have a direct correlation in students between how many problems they solve and the time it takes for them to complete in this the interview assessment, the problems in the interview assessment. Those who complete way more problems often have a much lower, faster time for their interview. That's just because they've been exposed to so many more patterns of thinking, because a lot of the time these coding problems are just pattern recognition, right? How many times have you seen like iterate through a string and only get the anagrams, or like iterate through the string and like upper and lower case it, right? You just need to be really exposed to different levels of patterns out there. And my final advice to everyone is to code in front of others often. It is so important to get involved with community and just coding in front of others, because your performance dramatically shifts when you're coding in front of others. I see this every week when I run my PEDAC sessions. Students will be like chipper, and then when the moment they have to code in front of someone, it's like everything they know goes out the window. So you just want to get used to coding in front of others, because people, like, nerves get the best of people, and you're making mistakes you never thought you would make. The prep course, the 101 and 110 series, have the most amount of community with them. Take it from me, once you get to later courses, it's really hard to find study partners and to have discussions about the material that you're working with. So if you forge the relationships now, it's a lot easier to maintain them throughout your learning journey. And launch school is just, community is like really what makes sometimes grueling learning a lot more bearable. So try and get involved with the community and just like get practice coding in front of others. Get comfortable with looking stupid in front of others, because that's totally okay, right? We're all learning. You don't have to appear to be a certain way or put all together in front of other people. Okay. So thank you so much for listening to me ramble for an hour and a half. That's the PEDAC process on a small problem for you all. Here is a feedback form. It would be a huge help if you could fill it out. It just lets us know what's working with these workshops and what's not. I'll be sticking around for just a couple minutes if you have any other questions, but otherwise, again, thank you for your time. We'll be starting the workshops again from lesson number 1 in a couple of weeks. I don't think it'll be next week, but it might be a week or two after. So if you want to learn with me, if you want to go down this hole with me again with more introduction to JavaScript material, then feel free to tune in the next weeks as well. Just keep an eye out in the Slack group channel when the next one's going to be. And I will see you around. If you have to run too and you have additional questions that maybe you thought of later, you can DM me on Slack. My name is Grace Lim, and I have the TA designation. So are the next seminars covering the same things? The next one, so this is lesson 6. So at the end of lesson 6, we cycle back to lesson number 1, and the lesson number 1 is data types and variables. So it's the introduction to JavaScript book. So it's pretty basic stuff, but I think anyone in 101 and 110 can benefit as well, since I just really break down a lot of the concepts. So yeah, we go from, the first one is data types and variables, and then number 2 is functions and variable scope. The third one is if statements and while loops in general. The fourth one is array iteration methods, like callback functions. Fifth one is object and array mutability, like mutating the arrays, pass by reference and pass by value for the fifth one. And then the sixth one is the PEDAC process. So we cycle through those 6 lessons over and over again. Yeah, thank you everybody for attending. This is great. A lot of attendees today. Thank you. So actually, due to a bit of a scheduling conflict, I do have to run earlier expected today. I usually stick around for at least 10 minutes for the questions. But as I mentioned, please feel free to DM me on Slack. I'm available. I'm literally always on my computer and like studying. So feel free to DM me and I'm happy to answer any questions you have. Bye. Thanks a lot, everybody, and I'll see you around.